Welcome, dear students. This is the compound interest. I will talk today about the compound interest, and this is the first episode or the first class of it. So, for the compound interest, if I want to bring the sum of the future value or the future value, we will just make it like this: future value will equals the present value multiplied by this is multiplied by 1 plus the rate, which is compound rate. The rate here is compound rate, and the power is the time. The power is the time is the power. Let's say, as example, now we have amount of $1,000 that will be invested with a rate compound rate of 10% for the period of 3 years. For a period of 3 years. In that case, if I want to get the future amount, which is, we will give it the sample of S will equals the principal, which is $1,000 multiplied by 1 plus R. The R is the rate. The rate is 10%. Well, 10% is 0.1. Like we said, this is 0.1. All to the power of the time. The time is 3 years. Then the time is 3 years. How to do this calculations? This will be $1,000 multiplied by 1, and 0.1 means 1.1 multiplied by 1.1, and the power is 3. How you do this on your calculator? How you will do this on your calculator? Simply, you will do like this. You will say, here we go. The sum of the future will be 1,000, 1.1. Again, I'm repeating this back. Power 3, which is the time, 1.1 power 3. So this will equals like this. 1,000 is outside, multiplied by 1.13. What you will do is, you will go to your calculator and just press 1.1. Then some calculators have this sign, which is the power. And some calculators have this sign, which is xn, power or xn. Then 3. Or you multiply 1.1 by 1.1 by 1.1. It will give you the same results as well. It will give you the same thing. So let's see the results of it, how it will be like. So like this, here is the calculator as example. Here is the calculator. So I will get 1.1 power 3 like this way. I will open on AC. On is here. Then 1.1. Here we go. 1.1. Then I will go for xn. I have here xn. This one. xn. I will press it xn. Then 3. That will equals 1.331. So this 1.1 power 3 will be 1.331. So this will equals $1,033. Okay. Now again, I'm saying 1.1 with the calculator. Some calculators have this, means the power, the sign of the power is this, or some other calculators have it x power n. Like my calculator, like I showed you, it has this sign. Then 1.1 power 3 xn3, this will give me this number. It will give me 1.331 if you do it with the calculator. When you multiply it by the principal, which is 1,000, that will give you $1,331. And this was the first example. here today I will talk about. Let's say that here this is an example. Sam invested $1,000 in a bank for 6 months with compound interest of 10%. Look at this. This is not simple interest. So the past was simple interest. This is compound interest of 10% annum, means that here. Calculate the amount after 6 months from now, which you will do. What you will do now is you get the future amount. So how we will get the future amount? By this way, then that will be because it's the interest is compound, as we see here, the interest is compound. So that's why we apply the law of not simple interest, but we will apply the compound interest. So now what I will do is I will say the amount or the sum at the end of this period will be the principal P multiplied by 1 plus R, which is the rate, power T, the time. Well, yes, like I said before, P is the principal and R is the rate and T is the time. Okay, then that will go to the next point. Then I will substitute. I have the principal is how much? $1,000. The principal is $1,000. $1,000 multiplied by 1 plus. The 1 is constant. The 1 is constant. We don't change it. 1 plus the R, the rate of interest is 10%. The R is 10%. So 10% will equals 0.1. It is the same as equals 0.1. So 1 plus 0.1. The power or the T, the time, is 6 months. Oh my God, the 6 months means as long as 6 months, I cannot write it 6 because if I wrote it power 6, that means 6 years. I have to convert it into part of the year. So it's 6 months divided by 12, that means 0.5. That will be 0.5 because 6 months divided by 12 months, this is half year. So it's 0.5. Again, we'll do the same thing. $1,000 multiplied by 1.1. This is power 0.5. Like we said, 1 plus 0.1, 1.1 plus this is power 0.5. Do it with the calculator, the same thing. We'll go to this and back. Here we go. Here we go. I will say, keep the 1,000 now. Just keep the 1,000 here. 1,000 is here. Multiplied by. Now what I will do is getting the amount, this amount, 1.1.5. So what I will do is just like this. 1.1 xn 0.5 equals 1048. 1.0488. Then when I multiply it, it will be by 1,000. When I multiply it by 1,000, this will equals $1,048.8. Okay, you got now the amount at the end of the period, but can we get the interest? How much is the interest, which I got? The interest will equals the future value minus the principal. The future value of S, which we got, is $1,048.80 minus the principal was $1,000. So what I got here actually as interest will be $48.08. So this is the interest which I get at the end of the period. So like I showed you just now, if the amount, the time is in years, then keep it the same way. The power will be the time. If they told you for 3 years, then it will be power 3. If the time was in month, you will change the months from months, convert into years. 6 months means 6 by 12. 3 months, 3 by 12. Because we are working usually on the financials, all the financials. Tabulations, we work on the time by the year. If I give it to you in days and I didn't tell you the year number, then you will divide by 360, 360. Okay, I will give an example now, inclusive example. And this is very important for you guys to compare between both the simple interest and the compound interest. It's very nice because we will share the ideas about the simple and the compound interest, and you will get it it will be very easy for you to understand it, and it will work well with you as well. So let's go for it and see what do we mean by the difference between to compare between both of them. That's fine. Let's go for it. I will share the screen now for a minute. Yeah, and just for you to see the example, and I will put the example also for you on your Google Class, so you will have the example. Okay, let's see now. Here is the example. Sam deposited $1,000 in a bank using 10% simple interest rate once. So this kind of example is two examples in each other. It's not one only, it's both of them together. Sam deposited $10,000 in a bank using 10% simple interest rate once and compound interest rate the other. Calculate the sum of the amount in the following cases. The first case, if the amount of money being deposited for 1 year. Okay, the second case, if the amount of money being deposited for 6 months. Third, if the amount of money being deposited for 3 years. I will take the main, include the main, like I'll extract the main info on the board. Then after that, we will go for the solution of it. So let's now go now for the example here. Let's go for our example. And what is saying? The example is saying what? Example is saying Sam deposited $1,000 in a bank. So the amount is $1,000. Sam deposited $1,000. So the amount is $1,000. That's fine. So the amount, $1,000 in a bank. This is the amount. So this is the present value. P will be 1,000. Okay. And I have also information that the interest rate is 10%. So R is 10%. The interest rate was 10%. I want to calculate it once in a simple and once in a compound rate. That's if the amounts for the time was 1 year and or time is 6 months, 6 months, and if the time was for 3 years. So this is, once I will calculate the time as 1 year, and 1 6 months, and 1 3 year. I will check out the results of each one of them. But in case I will work simple interest and compound interest. So this is considered as two examples in one example at the same time. We consider this as two examples instead of one example at the same time. Let's go now for the solution of this example. I will say here, this is the simple interest, and this is the case of the compound interest. How this goes. Now this will go like this. For the simple interest first, I will work on the simple. The simple interest is very easy. Let us work first on the 1 year. On the 1 year. For simple, once we will make it for simple, then once we will make it for the compound interest. Like we will assume that the 10% is simple, and then we will resolve it back as a 10% is compound. And we'll check out what is the difference between both of them. We'll check how does it differ. Let's see the simple interest first. So I know that the sum of the future value, or the sum in the future of the simple interest, will be 1 plus r t inside. Okay? But here in the compound interest, it's not like this. In the compound interest, the sum will be, look at this, 1 plus r power t. So if the simple interest, the t is inside the bracket, but in the compound interest, the t is the power of the bracket. And this is the first difference between them. So simple interest, like you see, and this is the compound interest again. The simple interest, the r multiplied by the t inside the bracket. But here, the r and power, all of them power t. The t is power up. Let's now consider the first solution, or the first example. If t was 1 year, and we will calculate it simple and we will calculate it compound. So if t is 1 year, then based on the simple interest, the present value, of course, we will multiply by the present value. In both cases, we have the present value. So it will be multiplied. The present value is $1,000 multiplied by 1 plus r. The rate is 10%. We said 10%, 0.1. Okay? This will be multiplied by the time. The time is 1 year. Then this will equals $1,000 multiplied by 1.1. Then this will equals $1,100. When you calculate it and finish it, it will be like this way. This is as a simple interest. Let's see as a compound interest. We said in the compound interest, here we go for the compound. The principal is 1,000 multiplied by 1 plus the ratio is the same, 0.1. Here is the power. Now the power is t. So power 1. Because the time is 1 year, so the power is 1. So what? So the submission based on compound interest. I'm working now. I finished the simple interest. I'm doing compound interest for 1 year. So it will be 1,000 multiplied by 1.1. The same thing, 1 plus 0.1, it will be 1.1. Power 1, which is the same, 1.1. Power 1 is still it will be 1.1. That will equals $1,100. So that means, look at this. For the compound interest, it's $1,100. For the simple interest, and for the simple interest, 1,100. For the compound interest, 1,100. We have the same results in both of them. That means for 1 year, the simple interest will be equals as the compound interest. Both of them will be the same. For 1 year, if I deposit the amount of money for 1 year. Again, for both of them will be the same if the amount was deposited for 1 year. Actually, because the power here, t, is 1. That's why anything by power 1 will be the same. So it's already. Again, I'm saying principal multiplied by 1 plus r by t inside. This if it was simple interest. But the power if it was compound interest. And this is the difference between the simple and the compound interest. Let's go back to the second case. This is the first case if it is 1 year. We'll go now to the case of the 6 months and check out which one will be more than the other or less, the simple interest or the compound interest. Actually, this example, like we are solving the question 6 times. 6 times, 3 for the simple and 3 for the compound. But we're comparing between the results of both of them. And this is the good thing in this example. Now, let's see back. Again, I'm saying the simple interest means that the future value will equals P, which is the principals, multiplied by 1 plus R is the rate, multiplied by T, which is the time. This is for the simple interest. But for the compound interest, it will be like this. P also, multiplied by 1 also, plus R, the rate of interest, but this is power the time. Power the time. The difference that the T in the symbol inside the bracket, t in the symbol inside the bracket, t in the compound power of the brackets, power of the brackets. So here we go. Now the amount is 6 months. Wait. 6 months, I can't leave it like this. 6 months, I have to divide it by 12. So this will be 0.5. So 6 months, I cannot leave it 6 because we said the month, I have to divide by 12. 6 by 12 will give me half year because all the measures of the simple and the compound interest in years. That's fine, that's great. Okay, let's go now for the example here. We'll calculate it first for simple interest. That means principal is 1,000 multiplied by 1 plus R. The R is 10%, which is 0.1. Like I said before, 10% equals 0.1. 10% equals 0.1. 1.1 multiplied by the time. The time here is 6 months, which is 0.5. Okay, so this will goes to like this way. This will be $1,000 multiplied by 1 plus 0.1 and 0.5. This will give me 0.05. 0.05. Then this will be 1,000 multiplied by 1.05. Then this will give me, when I calculate it, multiplied by the calculator, will give me $1,050. Now, it's your turn to make this when it is compound interest. For the compound interest, if it is compound, what we will do is the t is in the top or on the power. T is in the power. So let's go for it. The P is the principal is 1,000. Then 1 plus the R is the rate is the same thing. The rate is 0.1, which is 10%. The rate is 10%, 0.1. But now the T, the 0.5, will not be like the simple interest inside. It will be the top or the power of the whole bracket. So 0.5. So this will be $1,000. 1 plus 1.1 will be 1.1, but this will be 0.5. Like this way, it will be 0.5. So I will do it by the calculator, like I said, multiply by 1.1.5. I will go to my calculator and take the calculus of it, the same thing. I will do like here, C on first, then 1.1 xn 0.5 equals 1.048. 1.048 okay, 488. Well, let's see it like, keep it like this, take 3 digits, is more than enough. Then this will equal $1,048. So what do you notice from here now? What do you notice from here? You will notice that when we do, if the periods of time is less than 1 year, if the period of time is less than 1 year, then we will find that the simple interest is greater than the compound interest. That's if the period of time is less than 1 year. Let's see now. So if t or time is less than 1 year, then simple interest which is 1,050 is greater than the compound interest, because the compound interest is only 1,048. So this was the example, the second example, or the second case, which is 6 months. Now we finished already 1 year, and we will finish now 6 months. Then we will move forward to the 3 years. We'll move forward now for the 3 years. We'll make the same example, but we'll make it at 3 years, not 6 months or not as 1 year. Let's go and check out what is the results of this in the case to apply the third case. Again, I'm saying, the only difference between the simple interest and the compound interest, that in the simple interest, the t or the time will be inside the bracket, but in the compound interest, the t will be in the power of the bracket itself, the power of the bracket itself. So here we go. Now I will put it, the submission here back, but now I will work on 3 years. My work will be on 3 years. So I would say principal is 1,000 multiplied by 1 plus. I'm doing now the simple interest for 3 years. When the years are 3, the t will be 3. This is case number 3. We did this one, now we are doing this one. 1 plus dr is 10%, which is 0.1, like we said before, multiplied by the t. And the t here, like you said, is 3. Perfect. Then the admission or the sum future will be, S means sum future, means the value in the future, will be $1,000 multiplied by 1 plus 0.3, because 0.1 and 3, 0.3. It will be $1,000 multiplied by 1.3. That will come to $1,300. At the end, it will be like this. How about if it is 3 years and not simple interest, it's compound interest? Same thing will apply, but the t will be the power here. T is inside the bracket in the symbol, t is the power of the bracket in the compound. So that's how it will work. $1,000 multiplied by 1 plus r is 0.1, nothing changed, but the power will be, the t will be, the power will be 3. I'm now solving it as compound interest. I solved it as simple before, now I'm doing compound. Okay. This will be 1,000, 1.1 power 3. The same thing you will do, $1,000. 1.1 power 3 will go to our calculator and see it like this. 1.1, write 1.1. Then go to xn. xn, you have a button in your calculator, it's called like this, xn. 1.1, xn, press 3, which is the power. That will give you, let's see, 1.1 xn3 will equals 1.331. That will equals 1.331. So when I multiply it by that way, it will give me $1,331. Okay. In the simple interest, it was $1,300 for the simple, but for the compound, it is 1,331. So if t, or the time, if t is greater than 1 year, then compound interest will be greater than the simple interest, like you see. So the compound interest will be greater than the simple interest. This when if the t is greater than 1 year. If you, like here is 3 years, so the compound interest is greater than the compound are 1,331, and the simple is 1,300, so it's greater than it, and that's why it is that way. So this is about today's example. So we said today we talk about simple interest. This is the law of the simple interest. So the sum of the future will be the principal or the present now, plus multiplied by 1 plus r by t. R is the rate and t is the time. But for the compound, it will equals the principal the principal, multiplied by 1 plus r, which is the rate that is power the time. Power the time. So, and this is an example. It shows you the difference between the simple interest and the compound interest. If the period of time was 1 year, both are the same, like we saw here in this example. If the period of time was less than 1 year, then the simple interest will be more than the compound interest. If the period of time is I'm saying less than 1 year, then the simple will be greater than the compound, like I said. If the period of time is more than 1 year, then the compound interest, like here, 1,331, this is the compound, and the simple is 1,300. So the compound interest would be greater than the simple interest. I hope that you understand it, and I will put some examples also, like I did in the linear programming. I will put some examples for today's lecture on this thing with the solutions and with everything. You just in the final exam, it will be like it's exactly the same, but just with the changing in the numbers. But remember the ideas or the main ideas which we are working in. Thank you so much. Thanks for listening, and hopefully a good night.